He's looking. I did not. We're ready for the first presentation. Okay, here we go.
Obviously, I am not as cute as a little 9-week-old Clifford puppy, but I'm going to be talking to you guys about convection and basically how dogs use that to cool down during like a hot day. So basically, to glance over the topic of convection itself, convection is described in our readings kind of as a process of heat transfer from an area of like high temperature to low temperature through fluids. So basically things that move like rapidly throughout spaces, so like liquids and gases. So as you can see, as this like heating unit, this heater right here, heats up, basically what it's going to be doing is heating up the air and gas that is surrounding it, which is then going to become less dense and obviously rise, forcing the cold air that is at the top to come back down and then get heated, and basically it comes in this like circular motion. So kind of how does this apply to dogs? Well, if you think about like on a hot summer day, I know at like my grandparents' farm, they always have a fan running outside. Typically, you'll see like the dogs like all huddled around that to get cool. So basically, it works kind of the exact same way as this. The dog would be this heat source, this heater, and they're basically, their bodies are heating the air that is around them. And then that fan is going to be bringing in this cold air, which is going to be taking all of the this hot air that's surrounding their body and pushing it away, basically moving it away from them, keeping that air and body that's temperature around them to be more cool and cold. This same thing can be seen like with the dogs when they stick their head outside of the window in the car, and then obviously when they get too cold, they'll put their head back in. Another cool thing that I actually found. Can I just press the arrow?
The other way.
Okay. So there's this thing called a pet cooler carrier, and basically what it does, it's like a normal carrier for your dog. It like you put ice in the top up here. You can also use like ice packs or anything, and through convection, basically the cold air that sits at the top, the heat rises from the dog, then therefore heating up the ice, which will melt, sending the cold air down, keeping the like chamber or the carrier to about 10 to 15 degrees cooler than like a normal carrier, I guess per se. And then as the ice melts, it will actually go down into this pipe, which is sealed, and they can use to drink and get some cold fresh water.
I just saw that. That's neat.
Yeah.
Yeah, it'd be kind of neat to experiment with that to see if they say it's 10 to 15 degrees cooler, you could check it out with a thermometer and see how much it really.
Yeah, I didn't see any really like data about it. They just said on their site it was that, but it was also kind of extensive.
You always gotta be skeptical.
Yeah.
So you gotta check it out.
It was like $120. So I thought that was a little steep, but it's still pretty cool.
Yeah. Okay, so did you? I was distracted by the puppy as well as a lot of people. But did you say natural convection versus forced convection? I can't remember.
I mean, natural convection, I guess, would just be like wind, whereas forced convection would be more of like the AC or the fan.
Yeah. Okay. Excellent. Number 2 and number 3 at the door. That because we know we've got like 9 today, so we're going through great. Look at that green thing there. Press that. See it? Oh, next slide. Sorry. I got you. The next one. That's yours, right?
Yes.
Okay. Take it away.
Okay, so I decided to cover camels because they're really actually unique animals. During the day, they're going to maintain a body temperature about 41 degrees Celsius, and then at night they drop that down to 34. They mainly do this due to water preservation. They're not going to actually sweat unless they get really, really hot because the sweat's going to immediately evaporate. Some unique things about them is they can actually withstand a water loss of up to 25%, whereas like your regular mammal is probably going to be about dead after 4% loss. Their thick coat is going to keep the gain of temperature through radiation really low. That's mainly why they have so much fur, which typically with a desert type animal you wouldn't expect. As far as their long legs, those do two purposes for them. It keeps them away from the sun heat. So the heat is going to obviously be really hot down at the base where the sand is. And with these long legs, it allows two things. The heat gain from conduction is going to be low. And then also as far as convection, like Cole was just speaking about, that area underneath their legs really allows for that to help keep the body temperature down. And then other unique things about them is they can consume a really large amount of water in a very small time and then utilize that over a long span of time. And then that allows them to tolerate periods of long dehydration because the blood volume isn't going to change over that period of time.
Okay, and then of course we're partners, so I always add things. Can you write down the 3 sources of water for an animal? You know, there are 3 sources of water for any given animal. So it's like food water, like free drinking water, like Clifford's doing now. What's the 3rd water source? Metabolic water, and that's at lower left, right? Metabolize fat and you generate water. So, and yeah, if you've ever been on a beach on a sunny day, you linger in that sand barefoot? No, so it's really kind of neat that they're up high enough that they're going to gain very little from the hot sand. So they've been obviously adapted to this hot environment for a long time. Okay, thank you. Person 3 and 4 goes to the door. Metabolic water is the 3rd source. Second is the water in food. And the 3rd one is like Clifford right now, he's drinking water. Because you know, even dry dog food has 10% water. That big bag, if you look at it, 10%. So and then some animals, they get enough water from what they eat. They don't need any free water. There we go. Who's going to be up at the door? Okay, that's close enough.
I'm going to talk about how rhinos use different mechanisms of heat transfer. So they can gain heat from the sun, whether it's directly from the sun, reflected off of the clouds, or scattered by dust particles. They're going to gain it by conduction from the ground if it's hotter than the surface of the rhino, and radiation from the ground because unlike camels, they don't have long legs, they're pretty stumpy. If the air is hotter than the surface of the rhino, then the convection is going to cause them to gain heat, and convection is the movement of fluids, including air. Ways that they can lose heat is conduction if the ground is cooler than the surface of the rhino, convection if the air is cooler than the surface of the rhino, and evaporation, but rhinos don't have sweat glands, so it's either evaporating the mud that they rolled in or the water that they rolled in.
And remember last week we made this point, for any given animal, there's probably all the mechanisms are operating, right? The only one that's not shown here is condensation. But there's always usually 4, and it depends on temperature difference and of course speed of the wind. Okay, excellent. Chase's laser pointers. Did you see it? Yeah. Here we go.
Okay, so I did horses, and horses primarily use evaporation, convection, and conduction. For evaporation, it was said that they actually lost most of the heat. It was about like 10 to 20% of the heat loss was from just respiration during increased activity. And then they also lost heat depending on their surrounding environments, and stuff like humidity can affect the rate of heat loss. And then for convection, what happened with horses is primarily in the winter, whenever they have their long, thick coats, that traps in the heat particles that is coming off of the skin from the body heat. And one way it can be disrupted is whenever it's windy outside, it blows through their coat, and it actually causes those heat particles to be released, so then they can lose body heat. And then another thing they do for convection is they body clip if it's a working horse to increase the amount of, or to allow more efficient convection. And then for conduction, they use cold water to do what's called sweat scraping to try to get the body heat to go into the water molecules, so then whenever they scrape it away, it's removing the body heat to cool the horse off.
And you know, we said, I think last week, we said horses are one of the only mammals that sweats a lot. You know, they probably do it better than we do, you know, the way it looks like, all that froth. Anybody have any questions or comments? It was in this class, wasn't it, that we were talking about how if a horse is overheated, they pour alcohol for the evaporation? Somebody said that, yeah. So, very good. Okay, thank you. Okay, Robin, were you 4?
Yeah.
Okay, 5. So number 6 is going to the door. And I'll, let me see. You tell me if that's right. Is that
Yes,
yours?
yeah.
Okay, and then here's, see the little green vertical arrow, or the green vertical, yeah.
Yeah, okay, so I'm going to talk about countercurrent heat exchange. It happens in mammals too, but I'm going to talk about it in birds, especially ones that like wade in water. So it also can be like for Arctic birds. So it's like a circulatory adaptation that allows heat to be transferred from blood vessels or through blood vessels containing warmer blood to those containing cooler blood. So like in this example, like the artery alongside the vein, there's like an artery alongside a vein. So the artery has the warm blood that's coming from the body, and the vein has cooler blood that's been down in the water. But because of conduction, before the vein reaches back to the body, it's warm again. So that way it doesn't affect the bird's body temperature, like the core temperature. So this means that less heat will be lost in the foot due to reduced temperature difference between the cooled blood and the surroundings, and that the blood moving back to the body's core will be relatively warm, keeping the core from being cold. So that's how like ducks or any Arctic bird doesn't get like frostbite on their feet.
Because they're cooling off that blood. There's not a whole lot of valuable things in the foot anyway, like organs. Thank you. Yeah, I'm going to just talk a little bit more about this. So if you didn't write it down, it's counter-current heat exchange. Whenever you see that, that means two things are flowing in opposite directions. And so it's going to always have a gradient. So in this example, hi buddy, you got a little lint? Okay. Let's say this blood here, of course, what's the body temperature of most birds? Yeah, let's say chickens, 106, 107. So let's say if it's 107 here, like for example, you could write down 107, and then down here you need to write 106, and then 105, and then 104, and 103. So that means as the blood comes out of the body, because this is up here, and goes down, it's going to be cooling off, and that means heat has to transfer. And what you do is the green arrow, or not the green, the red arrows here are showing heat transfer through solid tissue. So that would be conduction, but the heat on the wall is by convection, because the blood is flowing. So you got convection going on here, then that wall gets warmed up, and then it's cooler over here, so heat transfers down its concentration gradient. So let's say we did 106 up here, and whatever we've got down here, 98, 97, whatever. So then across here, you just for the example, then you add 1 degree. So if this is, subtract, 97 down here, then over here it's got to be 96, because it only transfers from high to low. So then it's 96 here, 97 there, 98 there, and it's going to get warmer. So by the time you go back to the core, it's almost the normal body temperature, okay? So that's countercurrent heat exchange. Anybody know another famous countercurrent heat exchange mechanism?
In the testes.
Yeah, above the testis, and the testes, plural, there's this quite a large network of blood vessels that wrap, a lot of venous vessels wrap around the testicular artery. And what is that apparatus called? For trivia's sake. It's got a name. Nobody?
I know it.
Here we go. Say it louder. Piniform, P-A-M-P-I-N-I form, piniform plexus. And whenever you see the term plexus, that means like a network of something. It could be even nerves, but in this case it's a network of blood vessels. So yes, the piniform plexus because the testes operate at a lower temperature than the body. And if that thing wasn't working right, you probably wouldn't get good sperm production, right? Because if the testes get too warm, abnormal sperm production is increased. Here we go. We're ready for the next presentation. Is this it?
Yep.
Okay.
I'm going to talk about an actual Arctic bird from the previous one she was talking about it. The penguins and how they keep warm in negative 40-degree weather. So in this picture you see them huddling together, and most of the heat would be like towards the center, but there's also issues with the birds on the outside. So what they do there is they move in a wave-like motion, so the birds in the middle will have their turn on the outside, and the ones on the outside will have their turn on the inside. So the ones towards the outside that get most of the harsh, cold winds would move their feathers in a way so that the cold air would just go around them, and the warmer air that's from the middle will come towards them, and it'll keep them warmer, and that's the convection. They would also, when it's like not cloudy outside and it's more sunny, they would use that convection plus radiation from the sun to keep them warm. So that's how they use the multiple ones.
Now, did you call this as like, to me when animals get together, it's kind of like huddling. Did you use that term or
Yes,
not?
they huddle together.
Okay, they huddle together. What's it called when people do that? Cuddling, thank you. It's a little joke of mine. I tell her every semester, and sometimes it works and sometimes it doesn't. Okay, we're ready for the next presenter. You guys are good. Super. This is it? Yes. Yes, it is.
Alright, so I'm going to talk about how barns and fans are used to use forced convection cooling to keep the animals colder when it's hotter outside, essentially. So, as the airspeed increases, it increases the effect of the convection cooling. And so, as you increase the speed or decrease the speed, you can control just how much you can take away from their body, as far as heat-wise. And then heat loss by conduction, convection, radiation, all depends on the temperature difference between the cow and the surrounding environment. So obviously, the closer that the temperature gets between them, the less heat that can be taken away. And then once it actually hits the threshold point where the animal's temperature is equal to the temperature out there, the only way to actually cool off is through evaporative heating.
Yeah, I like that. Where did you find that diagram? Did you just Google it?
Yeah, I just
like
Googled
did?
it, and it was like the third or fourth thing that popped
What
up.
would we do without Google? Yeah, anyway. Anybody have any questions on that? Because temperature difference is a big thing. If there's no temperature difference, then there's no heat transfer. So like one good example of this is in the winter time when the temperature is a lot lower than our skin temperature, and the wind's blowing a lot, and it's a cool temperature. What's the weathermen always say? What's the parameter they tell you? They kind of give you a hint what to expect outside. Wind chill. So wind velocity, or the velocity of the flowing medium, is very important when your environment is cooler than you are. Okay, and so you might say let's say somebody says it's and the water's fine, the floor will be fine. Like you go outside and you forget your jacket, and let's say they say it's 10 below wind chill. Well, you're going to lose a lot of body heat, right? Because there's a big difference. But you know the tree out there has no concept of wind chill. It has no temperature to lose. So the tree that's, let's say the ambient temperature is 0, but the weather person says -20. The wind coming at the tree is 0. There's no -20 anyplace out there, right? It's a man-made construct that says if you go out now, it's going to feel like -20. Okay? So we'll be talking about that next week or probably Wednesday, but you got to be careful about wind chill, because wind chill only affects anything that has some temperature to lose, some heat to lose, like us. Or your car motor will cool off faster with the wind blowing, right? But once the car motor gets to the ambient temperature, the wind has no effect on it because there's no temperature difference, the wind coming at it. Okay, and then maybe one more thing since we've got it there, the evaporative sweating, which is good. Then on the hot end of the scale, when the environment is hotter than the animal, then evaporation is the major form of heat transfer. And that's basically what you said, because if the wind temperature is about the same as the body, the big thing then is evaporation. And so on the hot end, let's say on the cool end, you've got the wind chill chart. We'll do that, right? What kind of chart do you have on the hot end? The temperature humidity index, yeah. And that means at the hot end, humidity is everything. On the cold end, wind is everything. Okay? Okay, very good. Thank you. Let's see. Okay. This is it, right?
Yep.
Okay, good. Yeah. I'm glad I saved these. If you need practice with that green, and I'll get out of your way.
Okay, so I'm talking about convection, and convection is the process of air or water flowing by the skin and carrying away body heat. So your body responds to this to maintain your body temperature, and it does this through like goosebumps or shivering. So goosebumps, it impacts your sympathetic nervous system, and the muscles at the base of the hair contract, which stand the hair up. So you can see that in this picture, the too cold picture. And it creates dead space and decreases the thermal gradient. So you lose less temperature and your body temperature increases because of that. And then shivering is heat producing, so your skeletal muscles contract and it produces heat to maintain body temperature. So these pictures are just kind of comparing what happens when you're too cold versus when you're too hot. So when you're too cold, it shows that the hair stands up and it traps the air and it decreases blood flow in the capillaries, so your internal body temperature increases. And then when it's too hot, your hair is flat and it allows heat to escape, and sweat is secreted, so you can see the sweat glands in the picture, and it cools the skin by evaporation, and then blood flow in the capillary increases, which cools down your body temperature.
That's another nice little diagram. What's it called when the hairs stand up on end for this?
Piloerection.
Piloerection, yeah. Okay. Excellent. Okay, then E, right?
Yeah.
And I've got your PowerPoint here. Is that you, right? Let's just do this. If you need to, here's the pointer. See that green thing? It's not marked very well. Now let me, I guess I probably can't change that size. So there we go.
Okay. So I'm going to talk about the heat exchange regulation in ectotherms animals. So there are a few terms. So ectothermic is just a specimen getting most of their heat from the external sources. And I think poikilotherms and ectotherms, they are synonyms. They both refer to animals whose body temperature varies depending on the environmental temperature. Those two top graphs, it shows the differences between the endotherms animals and exotherms animals. So for exotherms animals, like lizard or like snakes or fish, they can tolerate a variety of they can tolerate body temperatures as low and also body temperatures as high due to the environmental changes. But for endotherms, they maintain a constant body temperature, they maintain homeostasis and regulate their body temperature both from the environment but also from their internal body regulation. However, for exotherms animals, their body temperature mainly depends on the environmental temperature, and they will regulate their body temperature through several ways, like reorientation from the position to get the radiation heat from the sun, or like boiling in the water to lower their body temperature or even increase their body temperature. And also for lizards, they can also do like color change to use radiation energy, radiation heat from the sun. So those are some of the ways in exotherms animals to change their body temperature based on environment.
They've got a lot of choices, and the key here is you don't have a confined animal. That's what we get into trouble with when we, confine animals in barns or pens or farrowing crates. all these animals kind of have free choice of where they're going to go, and the more choices you have, the better off, because then you can kind of self-regulate. Okay, thank you. Excellent. Okay, perfect. I'm going to just reset this for a second. The oops, you might have a tied up dog here. There you go. Okay, good. Okay. Let me find those two charts, the wind chill chart, and show you a little bit, and then the humidity index. Let's see, what am I looking for? I'm looking for Google here. Okay, so let's do wind chill. And we'll just explain it a little bit. There's all kinds of these things. I just want to find a big enough one. Okay, so when the ambient temperature is cool, then wind makes a big part of heat loss, and that's convection, right? So let's look at 5 degrees. 5 degrees ambient temperature. So if it's calm, then it's 5, right? There's no difference. And this is man-made, right? Okay, so then if it's 5 miles per hour, that's miles per hour, wind, then the weatherman would say today's wind chill is -5, and then it's -10, -13 stepwise. And you can kind of see they're trying to say frostbite times. Down here you have 5 minutes. Now who can remember the coolest wind chill you've ever experienced? That would be here. Where were you when the weatherman said the wind chill today is, tell me.
It was -45 freshman year, and it got canceled.
Oh,
It
okay.
was biology. We didn't have a biology exam.
Okay,
Yep.
minus 45 degrees Fahrenheit. And so it's like a little auction. Who can beat that? Anybody? That's child's play. I still wear shorts when it's -45 below wind chill. 80 below wind chill. Out in the middle of North Dakota in the winter time. And the weatherman said it's 80 below wind chill. How about the lowest temperature you've ever seen on a thermometer on the wall? Because when it's -45, you can never find that temperature anyplace, right? What's the lowest temperature you've ever experienced in terms of Fahrenheit on the wall thermometer? Not wind chill, but we're talking about this temperature up here. This is probably maybe 20 below, maybe?
Probably 20 below.
Yeah, probably something like that. Anybody had more than 20 below? -34, just the ambient temperature. And you were camping? Okay, that's kind of got to be a story. I don't know why you would go camping at -35. I have no idea. Now, I think I remember -30 on a thermometer, looking at and my uncle, who lives in North Dakota, remembers seeing -40 on the wall thermometer. So -40 right there, look at, it doesn't take much to get right there. That's 80. So the thing is, in North Dakota, if you're ever up there in the wintertime, here's what happens when it's so cold. You've seen a house moved by trucks, right? They put them on wheels and they move them, and they have to move electrical wires and all that kind of stuff. It's a hassle. They were moving a house one winter, and they got this smart idea of, why do we want to go around this lake when there's probably really thick ice out there? We'll just drive the semi and the house across the lake, because it gets like this thick, and that would support life. They have ice fishing contests. They'll drive a semi out on the lake or all of this stuff. Now, if you're familiar with ice, there's one warning sign, because I've fallen through ice when I was ice skating with a dog. Anyway, that's another story. Up to here in water. Anyway, it starts cracking, and if you're familiar with it, you say, oh, S-H-I-K. They're driving this truck with the big house. I saw a picture of it. It was like before, 2 stories at least. Those big old farmhouses. But if you go across the lake, you don't have to raise any electrical wires. There's nothing out there above the lake, right? They're driving. They're about halfway. It's like a mile, down. It's kind of a long lake. The driver hears some cracking. And of course, you can't really speed up. There's ice. You know, you can only go so fast, and you know, you can barely move anyway. He was smart enough that said, this is not working. He went and unhooked the house and got the semi, and he looked in the rearview mirror, and the house was going like this. It had broken through the ice and disappeared. It was deep enough. Now, can you imagine calling your boss? John, you know that house I was supposed to move? That's a true story, yeah. Okay, so that's the wind chill chart. And then let's do the opposite. That would be the temperature humidity index. So then you would go like this. Temperature humidity index pops right up. Maybe I switched it before. So then you have another chart, and this one happens to be for cattle. And the thing is, now convection has nothing to do with this. So the parameter is the absolute temperature, and unfortunately that was up here on the last chart, so this is flipped. But it's ambient temperature versus relative humidity. So when you've got, let's say, 80, well, down here, we'll go to 86. If the humidity is 30, then the temperature humidity index is 75. So that's relatively dry, let's say it that way. So then yellow is kind of in your alert zone. This is for beef cattle. Then this darker yellow is danger. And then the red, for sure, you shouldn't move any animals. Now, that one thing is, beef cattle aren't that metabolically active. What cow is the walking furnace? Dairy. So maybe for Wednesday I'll try to find a dairy thing, but this would not apply to dairy cattle. Because dairy cattle are a walking furnace when they're milking. So all the numbers would be different. So that's the thing. Wind chill isn't different because that's kind of a man-made construct, and the person looks at the chart and says it's minus 20 below wind chill. But you have to know what animal you're talking about here and what the state of the animal is. Okay? I think I'm going to end there. We had a great day. Say you have a little time to interact with the puppy. The puppy's going to stay around a little bit. Allison, I'm going to move that water over here. Just get it out of the way. Clifford. Yeah, say goodbye to the puppy.